Testing. Okay, so we will be doing our exercise 9, which is transferring bottles, right? So the parameters of this exercise are saying you should be familiar with a latching circuit we should familiar with latching circuits with varying performance features, and should be familiar with the various types of end position monitoring, and you should be able to select the type of and position monitoring of a pneumatic cylinder, right? So the technical term is saying bottles need to be diverted in groups of 3 from one conveyor to another by means of a divert, right? And then they're saying after the signal being switched on, the system should run continuous. It should not stop up until a stop signal is generated, or yeah. So like the keywords from the description of the process, you can see that they're saying the system should be able to run continuously, right? Which means that the system, once you press the start push button, it should be able to advance, or maybe also advance, retract on its own up until you press a stop signal, right? Or a stop push button, right? That can stop the process, right? Or stop the signal that's been generated, right? So which means, like, since there's a stop button that's generating a signal that needs to be cut off, it means that the signal that we're going to be sending it's going to be sort of like continuous or latched, right? And then we need to stop that signal by cutting it off using a stop signal, or as I mentioned before, usually use a dominant braking switch, right? And then the process is saying the sequence is started by pressing a push button, right? And then, so here they're telling us what's starting the sequence, right? And then they're saying if 3 bottles are present, right, the diverting cylinder should advance, right? So if you look at this, right, the only way in which if the only way in which 3, so now we're focusing on the second statement, right? If you look at this process, right, the only way in which 3 bottles could be present here, so that they could occupy the space so the cylinder could advance, is if cylinders in the retracted end position, and then the 3 bottles come in to occupy the space, and then from then on, the cylinder can advance, right? Which means, tells us that for the cylinder to advance, it needs to be in the retracted end position, right? So that like the 3 bottles are able to fill up the space before it can advance. So now I can conclude that I have to fill 2 conditions for my cylinder to advance, right? The start push button has to be pressed, and the cylinder has to be in the rotated end position, right? And they're saying the bottles are then diverted and transported to a second conveyor belt, right? And then they're saying the sequence should be stopped by pressing a second push button, right? That's the stop signal that's gonna cut off the signal, right? So they're saying we should utilize latching characteristics. We should demonstrate dominant break-off characteristics, right? So now we go to our FLUIDSIM, right? So now we're gonna get our our compressor, right? And then we're gonna get our air service unit, right? And then in the context of this exercise, we'll be using a double acting cylinder, right? And then now we need to decide on the type of solenoid valve to use, right? The 528 in particular, right? So, like, as I've probably mentioned before, to control a double acting cylinder, you cannot use a 3-way. It's always a 5-way, right? So now, let's say now we're deciding on these different kinds of 5-way, right? So now, to ensure, so since they said our system should run continuously, right? And for, if you look at this, for the system to be able to push off the bottles, right, to the second conveyor belt, right? the system should, or the cylinder should be able to fully advance to the front end position, right? And then retract and then advance like it. So now, if you're considering using this one, right? So now, if we have two conditions to fulfill, right? In us trying to fulfill those conditions, right? So we'll need to define the backend position and need to press the start push button, right, to actuate, let's say, Q0, this side, right? So in actuating the Q0, yeah, in actuating the Q0, you'll notice that as soon as the cylinder leaves that certain position, so like one of the conditions for the end, from the end condition that will must cause the cylinder to fully advance. As soon as the cylinder moves out of the back end position, the spring, the circuit will open, right? And then the spring will snap the spring will snap the cylinder back to its position, right? So the cylinder will not be able to fully advance because as soon as it moves out of the as soon as it moves out of the retracted position, one of the conditions are not fulfilled, and then the cylinder snaps back, and then so we don't fully advance at all. So now, to make sure that the signal is contained, right, we have to use a bistable valve. Since the bistable valve, it has a latching mechanism that's going to allow the cylinder to advance without any spring that's going to snap it back, and then it can only snap back, right, by a defined parameter, right, which is maybe a sensor or a secondary push button. So now we'll be using the bistable 5-way, right? And then now we have set up our pneumatic system, right? So yeah, this is our pneumatic system. Now we have to set up our electrical side, right? So now first we get power, right? And then we rotate this to 180 degrees, and then 0, this side, and then right. And then now I can start building in a second, right? And then, so if we go back here, right, they said the system should run continuously and it should be cut off by a stop signal, right? And the general conditions are also saying we should utilize the latching circuit with a dominant break off characteristics, right? Which means, so now they're saying the system is started by a push button, right? So but for system to remain continuous, you can't be pressing the push button every time, right? Which means this is the signal we need to latch. We need to latch the signal of the start push button, right? And then, so now we'll get our push button here, right? And then we need to send, if we're assuming that we are using, which is probably the truth, right? We are using indirect actuation, right? Our signal would go to our the relay, right? And then in the previous, I think exercise 8, I've already explained how latching, what's the logic behind latching. So now you latch using the changeover like this, and then to here, right? And then before you join this, you have to integrate the dominant break signal, right? Which is this push button here, right? To go to connect here and then connect here. So this is gonna be our start push button, right? So you can put this as B, shift underscore start, right? So it's gonna be our start push button, and then now we have to latch using the output, right? Which is when I latch using R1, right? And then this is gonna be your stop signal, stop PB, right there, something like that. And then, so now, what other this? So now for a cylinder to advance, it also needs to be in the refracted end position, right? So now to define that refracted end position, let's say you can either, so since they didn't specify here which kind of sensor is supposed to use, you can use any sensor you want, but let's say with, like they said, we're using a magnetic proximity switch, right? So we get our magnetic proximity switch connected to a relay on the side, and then to power the side, and then to ground on the side, right? And then also back to ground on the side, right? And then we'll label this our relay number 2, our R2, right? So we'll use this with this sensor to read the refracted end position, which means we need to define it as the back position, let's say the position of back position, right? So, and when we come here on the cylinder, also need to define the back position, right? Which means it's gonna be our BP, right? And then which is gonna be at 0 and 0, right? So now you can see it's currently closed, right? And then now we need to set up our end condition. So our end condition, they said we need to press the push for cylinder to, for our operation to start. We need to press the start push button, and the cylinder needs to be in the set end position, right? And then you set up the end condition that's gonna send the power to the to your first solenoid, right? So now you're gonna say this is for relay 1, which is for the start push button, right? And then it's gonna be your R1, right? And then your second condition, it's gonna be here, and then back to the ground. No, sorry, not to the ground. It's gonna be your R2, right? And then it's gonna send the signal this side to actuate the cylinder forward, which let's name the side Q0, and we name the other side Q1, right? And then it's gonna send a signal to Q0 to make it actuate forward, right? Using the solenoid valve, right? Here, and then back here. Which is this gonna be your Q0, right? To make the cylinder actuate forward, right? And then now after the cylinder advances, right, it needs to fully advance and then go back, right? So what can you use to detect that the cylinder has reached the front end position, right? You can use another sensor, right? So that sensor will serve two purposes, right? It will ensure that the cylinder is fully advanced to push off the bottles to the second conveyor belt, and also that the cylinder can be actuated back to its position, right? So now we'll use, again, I will continue using magnetic proximity sensor, but a limit switch can also be used, right? So again, connect this to, and then back to here, right? And then get our relay, and then back to ground, right? And then since we already have R1 and R2, we're gonna label this R3, right? And then now we're gonna send this R3. So now this what you call this sensor is in the front end position, right? To check that the cylinder is fully advanced, and as well as to ensure, or to help us make sure that we are able to make the cylinder go back, right? Using Q1, actuating it on this side, right? So we're gonna get our relay, our solenoid valve, right? Which is gonna be switched on by our R3 on the side, and then going back to ground, right? So this is gonna be our R, which is gonna turn on that's fully advanced, and then this is gonna be our Q0, right? Our Q1, right? That's gonna make our cylinder go back, right? And then now we also need to define the position of this sensor, right? It's gonna be at the front position or front fully advanced side, right? And then also need to go back to the ruler to define the position, which is FP, which is at 100, 100, right? And then okay. And then now if we our system now that running continuous, so not doing the marketing something focusing on about my venture point. Now I read that's going to right. Everything else, right. So that's how you design a system that can run continuously, right? And that's our solution to exercise number 9.